Hello, this is the section 6.1 lesson. So far in this class we've talked about the operations of addition, subtraction, and multiplication. Now in chapter 6 we're ready to talk about division. So in this section we're going to talk about the interpretation of division. I start off with a definition of division, talk about some different types of division problems and how we can set up a division problem. And the approach that I take here is going to be a little bit different than what the book takes. So let's start off with a definition of division. So a division problem looks like this. A number divided by another number equals a third number. So A divided by B equals C means the same as A equals C times B. We can think of division as like the opposite of multiplication, and this right here is just a formal way of stating what we mean by division as the opposite of multiplication. So let's do a quick example to illustrate this definition. Let's take the division problem 8 divided by 2 equals 4. And we know that's true because 8 equals 4 times 2. If we match things up with our definition, A is 8, B is 2, C is 4. And then over here on the right we have A is 8, B is 2, and C is 4. So this is what we mean by division. 8 divided by 2 equals 4 because 8 is equal to 4 times 2. Okay. Now some different notation that we use for division is given by these four examples here. So A divided by B, this symbol here, this notation, this is the notation that we're going to use most frequently. Sometimes we use a fraction notation, A over B. That means the same thing as these two symbols mean the same thing. Now in a few sections we're going to talk about the connection between division and fractions. There's a connection more than just notation, but we'll talk about that connection later on. Sometimes we'll use this slash notation. I'm not a big fan of the slash notation. My high school math teacher always called this the sloppy slash. So we are not going to use this notation very much. This notation here we'll use when we talk about the long division algorithm. Now the number B in a division problem, that's the number either on the bottom or on the right or on the outside. B is called the divisor, and then the other number is called the dividend. Now we said that multiplication and division are like opposites of each other. In technical mathematical terms we call them inverse operations. Now addition and subtraction are inverse operations, so let's make an observation about an addition problem and the related subtraction problems. Let's take this addition problem, 5 plus 3 equals 8. Now from this one addition problem we get two subtraction problems. 8 minus 3 equals 5 and 8 minus 5 equals 3. So these two subtraction problems are equivalent to this one addition problem. So from one addition problem we get two different equivalent subtraction problems. Now why is that significant? Well, let's look at multiplication and division. Those are inverse operations. So let's take the multiplication problem, 5 times 3 equals 15. From here we get two different equivalent division problems. The first is 15 divided by 3 equals 5, and the second is 15 divided by 5 equals 3. Now we know that both of those equations are true because 3 times 5 equals 15, and likewise 5 times 3 equals 15. So from this one multiplication problem we get two equivalent division problems. Now why is that significant? Well, let's review the meaning of multiplication. Multiplication means a number of groups times a number of items in a group equals a total number of items. So 5 is a number of groups, 3 is a number of items in a group, and 15 is a total number of items. So in this first division problem, 15 divided by 3 equals 5. So here this 15 divided by 3 represents a number of groups. In the second division problem, 15 divided by 5 equals 3, so 15 divided by 5 represents a number of items in a group. So the significance of this is that it illustrates that there are two general types of division problems. The first is what we call a how many groups type of division problem, and that's where we take a total number of items and divide it by a number of items in a group, and that's going to give us our number of groups that we have. The second type of division problem is called a how many in each group type of problem. And in that type of problem, we're going to take a total number of items and divide it by a number of groups, and that's going to give us the number of items in a group. Okay, so two types of problems: how many how many groups, and how many in each group type of problem. Now, this is where I'm going to start doing things a little bit differently than the book does. The book doesn't really give any good strategies for how to determine what type of problem a given division problem is. I'm going to give you a little graphical tool that we can use to help determine what type of problem we have and how to set up a division problems. So let's take this first example. Miss Karen has 10 candies. If she gives out 2 candies a day, how long will her supply of candies last? Okay. So we're going to start off with these 10 candies. We're going to distribute 2 candies each day. The question is, how long will her supply of candies last? So division problems usually involve taking some group of items and distributing them equally among some sort of groups. And so to help illustrate this problem, we're going to draw a picture down here. At the top of this picture, we're going to put our total number of items. At the bottom, we're going to put our groups, and in the middle is going to be the number of items in a group. And so the total number of items that we're working with is our 10 candies. So let's draw our 10 candies up here. Okay. Now at the bottom, we have our groups. So we can think of each of these days as like a group. And so I'm going to draw a couple of blanks here. Day 1, day 2. Now I don't know how many days there are going to be because the question is how long or how many days. So I'm going to draw a ... question mark. Indicate that I don't know how many groups I have. Now in the middle, we're going to put our number of items in a group. Well, we're told in the problem that she's going to give out 2 candies a day. So that means we're going to draw an arrow like this and put a 2 beside it. And another arrow right here, put a 2 beside it. So this picture illustrates that we're going to have 10 candies, and we're going to give 2 candies to the first day, 2 candies to the second day, ... I don't know how many days there are. And so this picture here illustrates what's going on. How we've got these candies, we're distributing 2 candies to each day, and we don't know how many days. So here's just a cleaned up version of that picture. And so because our question mark is down here at the bottom, which means that we don't know how many groups we have, we see that this is a how many groups type of problem. And so to set this up, or to solve this problem, we're going to take our total number of items, which is 10, and divide it by the number of items in a group, which is 2, and this is going to give us our number of groups, question mark. Now to solve this division problem, we're going to convert this over to an equivalent multiplication problem. And the equivalent multiplication problem is 10 equals question mark times 2. And so now we're going to reason through to find the solution. We think what number times 2 equals 10? Well, the answer is 5, so question mark equals 5, and then we'll put a label on it, 5 days. So there's our answer. So our supply of candies is going to last 5 days. Now let's do a similar example. Again, Miss Karen has 10 candies to distribute equally among her 2 students. How many candies will each student get? All right, now this is a very simple problem, but again, we're using this to illustrate this procedure of drawing a picture that illustrates our problem and using that to determine what type of problem it is and how to solve it. As we mentioned before, division problems usually involve distributing some objects equally among some groups. Now this word right here, equally, is very important. We always have to distribute things evenly among these groups. If we don't do it evenly, then it's not a division problem, and there may not be any way to solve it. But because it's equally, that's a simple division problem. And so at the top of our picture, our total number of items, we've still got our 10 candies. But now we're not distributing these candies over a series of days, we're distributing them to her 2 students. So at the bottom here we're going to put student 1 and student 2. Now we don't know how many candies each student is going to get, so we're going to draw an arrow here, put a question mark beside it, another arrow and a question mark beside that. So we've got our total number of items at the top, our groups at the bottom, and our unknown number of items in the middle. So here's a cleaned up version of that picture, and because our unknown is in the middle, we don't know how many are in each group, so this is a how many in each group type of problem. So to solve this, we're going to take our total number of items, 10, and divide it by the number of groups, which is 2, and that's going to give us our number of items in a group. Now, this is the same division problem that we just did in the previous problem. We could convert this over to an equivalent multiplication problem. 10 is equal to question mark times 2, and so then we reason through it. Question mark is equal to 5. But now this isn't 5 days or 5 students, this is 5 candies. So there's our answer. Okay, let's do one last example here. 12 cups of water fill 3 identical buckets full. How many cups of water are needed to fill 1 bucket full? Now, notice that we're going to take our 12 cups of water and we're going to distribute them among these 3 buckets. Now, notice that it says that these buckets are identical. So that means each bucket is going to get the same amount of water. That's very important. So in our picture at our top here, we can think of each cup of water as an item. So we've got 12 cups. And then we can think of a bucket as a group. So here's bucket 1, and here's bucket 2, and here's bucket 3. And we don't know how many cups are going to go in each bucket, so we're going to draw an arrow there, question mark, beside all of these arrows. So there's our picture. We're going to take our 12 cups of water, distribute them evenly among our 3 buckets. We don't know how much water is going to go into each bucket. So here's a cleaned up version of that problem, or that picture. And we see again that our question marks are in the middle, so we don't know how many items are in each group. So this is a how many in each group type of problem. So to solve this, we're going to take our total number of items and divide it by the number of groups, which is 3, equals question mark. And so an equivalent multiplication problem is 12 equals question mark times 3. So we think, what number times 3 equals 12? And so the answer is 4, and 4 cups is our units here. So there we go. That's how we can draw a simple picture to set up a division problem. Use that picture to write down our division equation, and then convert that over to an equivalent multiplication problem, and how we can solve that by just reasoning through it. So that's it for this lesson. Your assignment before next class is to read section 6.1 from the textbook.